This is number 24 in 7.5 work section. This says with gas weighing 42 pounds per cubic foot, the top of a cylindrical gasoline storage tank is, to simplify it, is 7 feet below the ground, and we'll be pumping the full gas tank, which is 5 foot in diameter and 12 feet long, respectively. We'll be pumping all that gas 7 feet above the top of the tank to ground level. So to start, this is clearly a work problem because we will be dealing with an incremental force and a constant distance. So to begin, we will draw our diagram, which is as shown. This is underground, a horizontal tubular tank with a circular base, and this is where we will draw our graph. And as you can see, we will center it in the middle of we'll have the middle of the circle at the base of the tank, and which is 2.5 feet in radius and 12 feet long. 42 pounds per cubic foot is our density, and 7 foot total from the top of our tank. So to begin, we will deal with we will talk about, okay, what are the two parts we need to solve for work? Well, work equals force times distance. In this case, we know our distance, or we'll start with force. Our force needs to be density of our gas times the volume of our gas. The volume in this case will be the change in volume. And we'll be dealing with this so that we have a incremental volumetric rectangles, cubic rectangles. And we'll be pulling delta y, which will gradually get bigger once it hits the middle of the circle and then gradually get smaller. So after dealing with that, we will have delta y, which will be our changing height, our length, and our width. That's height, length, width. Well, in this case, we have our delta y, length times our length, which is 12, and our width. Now, in this case, our width is going to be 2x. How do we get that? Well, because our rectangles, our representative rectangles, will be changing slowly in its length, as I should say, we have one x distance here and x distance here, which will be changing as we take our infinite rectangles up to the top. So, as you can see there, with x, starting at the origin, we know that the base of our tank will make x squared plus y squared equals 2.5, which is our radius squared. Solving for x, we get x equals the square root of 25 over 4 minus y squared. And that's the x we will replace there. So, thus, combining this equation with our volume, we have our incremental force equals 12 times our density, which is 42 pounds per cubic foot, times 2x, which is 2 the square root of 25 over 4 minus y squared, times delta y, which is our height. And next we need to solve for our distance. Well, our distance is going to be from the top of the ground, is 7 foot to the top, to our origin, which, adding that up, 2.5 plus 7 will be 9.5. So our distance is going to be 9.5 minus y. Now, what would be expected is, oh, why isn't it 7? Well, it's not 7 because we made our origin the center of the circle. And the center of the circle is 2.5 feet below the top of the tank and 2.5 feet above the bottom of the tank. So total, you will be taking the liquid at the bottom of the tank will be traveling 12 feet up, and the liquid at the top will be traveling 7 feet up. So after finding that, we can take the integral of the incremental force times the distance with the limits negative 2.5 feet, 2.5 feet, because those are the points concerning the origin, times our distance, which is 9.5 minus y, and our force, which, multiplying this out, will equal 1008 times the square root of 25 over 4 minus y squared, whole thing dy. Now, here it's just taking your integral and using the first fundamental theorem of calculus to plug in your limits. In the end, you will get 29,925 pi foot-pounds, which is the work it would take to pump the full tank of gas 7 feet above the ground.